Good afternoon and welcome you all. This is an amazing event to be in. Thanks to Linux Foundation for making this happen. OSS Summit in India, so first of its kind. And I'm very excited to be here and present on this very important topic. And I sense it as a very important topic. I'll let you know, like in the course of this session, you will get to know why it is very important for all of us. And I have with me Vignesh and Karthik, who are part of my team, and we will be presenting jointly here a few slides. So I named this title as Who Moved My Cheese, and I won't ask you guys to raise your hand to say like how many of you have read this book, because for India this is not something new. We always are into this terminology of who moved my cheese, right? So basically, just to say like how it correlates to the topic that I am presenting here. So in this book, basically the characters are mice. So they are like they are in an environment where they have plenty of cheese and they live with it. And one of the mice sees that the cheese storage is shrinking and it starts preparing itself to go find for food, and other one just relaxes and stays there, and it realizes one fine day that there is no more cheese left and it starves to death. Now this is what is going to happen if we are not prepared well in advance for things which are very important for us. So what is cheese in our case? First thing is the business model. We might be manufacturers, or we may be coming from software service providers or hardware service providers, open source project maintainers, and like the owners of open source project. For all of us, we follow a very decent business model, right? Like manufacturers, they manufacture the product and they put it on the stand, they sell, and they are making money out of it. And service providers, they have a very good service model, and where they build their product, software as a product, hardware as a product, and they have a business model. So these business models are going to change as we get more into cybersecurity compliance. So we need to prepare ourselves before those standards get in place. Similarly, the infrastructure that we are using today, the build infrastructure, the test infrastructure, and the source repositories that we are used to, and just now we had a very good session on SBOM and how we are going to use these tools. So all of these things should be refreshed. Why are we talking about SBOM today? Why are we talking about so many LLMs being running on GitHub and projects like this? This is all are preparing ourselves for cybersecurity compliance and catching vulnerabilities, handling security threats, and these things, right? So lot of things on the infrastructure also is going to change. Revenue, earnings, and profits, right? So all these things that I just spoke is not coming for free. They all need money, and the product cost, the end equipment cost, is going to take a hit in terms of profits, right? You need to fund these things, and this fund has to come from your product and the cost of the product. So these are the things which I call as like these are my cheese, and then these are going to change, and before it gets into more stringent compliance, it's better we get prepared for ourselves. Now, who is moving our cheese, right? What is happening? Who is moving our cheese? So there is this Cyber Resilience Act, and this is an European resolution which has been passed, and it is coming into effect. And the main goal of this CRA is to enhance the cybersecurity standards. So it is bringing very good cybersecurity compliance for making the end user product more secure proof. And every digital product, whether it is software or hardware, so any digital element in the product, it has to be secure proof, right? So that's the goal of this. So when this CRA takes into effect, and we all will have the problems that I just mentioned in the previous slide. I don't want you to think CRA is a villain here, right? Like I don't want you to go after them. They are doing their job, and that is the best thing that they are doing at this point of time. But the challenge is on us to make sure we are able to cater to these rules and regulations that are coming into effect. So what, right? There are so many rules, so many acts in the system today. So this is one more act, and this is one more rules or regulations to follow. What is the big deal? The big deal is, like, if we are a manufacturer and if we don't comply, and if we are caught for not complying, then there are fines. The fines are very, very exorbitant, especially like you can see 15 million euro, and 2.5% of your global annual turnover of that product. It's a huge money. It's not at all a simple money that we are talking about, right? And but when is this happening? Is it happening tomorrow, day after? The rule has been established, it is approved, and it's already taking into effect. Like, we are learning about it, and it will go into effect on December 11th, 2027. So we almost have couple of years to see when these fines and things may get applicable. But I am saying this is CRA is an European regulation. So what is in it for me? I am selling my products in China or US or Japan or Asian countries or India, right? But this is not only meant for European Union. There are similar cybersecurity compliance and rules and regulations which are being discussed, and similar laws are getting enforced in other regions like US, Australia, Japan, and other places. So this and CRA is leading here. The specs that CRA has put out will be in alignment with the other regions. So this is going to take effect globally. It is not meant for an European region. So I just talked about cheese, and I talked about multiple things on CRA and things, and I told you CRA is not the villain here. Now, where is this all getting started? Like, what are we supposed to deal with, or what are we dealing with? I will give you a very simple example to make it easy for us to understand, right? So assume I am a manufacturer and I am shipping my product today in 2025, okay? And then in 2028, I get to see a simple line of code in my software which I have shipped, which is part of the product which I have shipped in 2025, and this piece of code is doing nothing but initializing the data pointer to some null value. If this code is missing, then for some reason my system can crash, my product can crash, and I can trigger that crash from an user space activity, whether an app or something. Like, from an user space activity, I can trigger this line of code, and this line of code is missing, due to which the system may result in crash. Now this is called vulnerability in the system. So this is a security risk. Now what am I supposed to do? I am a manufacturer. As soon as you see this thing, you are supposed to report it within next 24 hours, register this vulnerability in the CVE system. Get a CVE assigned for this. Not just assign or catch the vulnerability, also fix it. And once you fix it, you have to now deploy on the products which are already shipped in 2025. Like, I am taking you in the forefront, right? You are in 2028, and you are now supposed to upgrade all your products with this fix. And this is not at all an easy thing, right? You are not recalling all these equipments back into your factory and fixing it. It has to be over the air update. Now, if manufacturers are not tuned to this kind of an infrastructure, this is a big problem for them. So can you imagine the complexity here? Like, I am a manufacturer and I am running a shop with maybe 10 to 15 engineers, and we are doing an excellent product, and here comes the code from nowhere. I don't know where it came from, and as soon as an user creates or triggers an activity and my system is crashing, everybody is saying this is a security threat and a vulnerability, and I am supposed to act on it. This is a too much burden for me as a manufacturer to handle. Now we are supposed to fix these things, right? And where to report the vulnerability, where this code came from, how am I supposed to fix this, how do I deploy this fix into the end equipment, right? And more importantly, all these security fixes have to be addressed for years to come, for the life cycle of the product, minimum 5 years, right? So all these things are significant challenges that are getting into effect from now till 2027. We have to prepare for this from now, be ready by 2027, right? So just in Linux kernel today, we are seeing 50 plus CVEs every week. You can go to kernel.org and you can see, right? Just one kernel component, you are seeing 50 CVEs. If you take your project, entire software stack, there are protocol stacks, there are firmwares, there are so many binaries, everything getting linked to build a product, right? Just imagine how much massive software we are dealing with here, and where all can these CVEs can exist, these vulnerabilities in the system can exist, and how difficult it is going to become to fix all of these things. Now, where are these vulnerabilities? How to find them? Now, you understood like who is your cheese and who is moving your cheese, and then CRA is not your villain. It's actually these vulnerabilities which are your true villains, and you are supposed to catch them, notify, fix them, right? This is what we are getting into. Now, where are these vulnerabilities? They can be anywhere. If you have multi-core SoC, then every core runs some piece of code, and every code will have this kind of vulnerability. Taking a simple example, if you have a multi-core system on chip or a processor, the code starts from boot ROM itself. Like when you boot the device, when you turn on the device, your boot code starts. And on the main core, you may start running Linux, right? And then you have kernel, device drivers, you have file systems, then you have protocol stack, frameworks, user space applications. So vulnerabilities can be in any of these areas. If your SoC also has MCU cores, like remote core, there is FreeRTOS running or ThreadX or any kind of remote core Zephyr software running, right? Even there are networking stacks, your protocol stacks, your device drivers and things. So vulnerability can be here. If you have accelerators, like for an ISP, camera ISP, or a power management accelerators and such things, so you can have vulnerabilities in that code base as well. If you have NPU, DSPs, and image processing, audio processing cores, the vulnerabilities can be in that piece of algorithm as well. So it's huge. You are dealing with a completely different system altogether. And just to give a simple example, like if I take a very simple tiny file system in Yocto and I run SBOM and see the bill of material of the software, I am seeing more than 2.5K projects in that SBOM. That means so many utilities are being used, so many projects are being used, and each have multiple files, right? So it's a huge software that we are dealing with. And you had a very good session on what SBOM is just previously, so I will not go into the definition, but it is basically bill of material, right? Where this software came from in my product? That is basically bill of material. Now, vulnerability in a nutshell, I took these key points from Greg KH's Linux Foundation Plumber's talk from last year, so where he clearly defines what vulnerability is in the kernel and what is not. So, what vulnerability is? Very simple. Anything that can trigger from user space a crash or reboot, which a piece of code which you can break or which is not freeing up itself properly, incorrect boundary checks, denial of service, logic errors, these things can be called as vulnerabilities. What is not, like something very closely associated with data corruption logic and such things, they are not calling it as vulnerability, but I doubt that first bullet here because data corruption and loss is also a security threat. The performance issues are not considered as vulnerabilities. Like for some reason, if your device is starting to run slow after installing an app or something, that is not treated as a vulnerability. Similarly, if you have some bugs and you are fixing those bugs, they are not termed or counted into vulnerability thing. But these definitions are going to change as we evolve in few coming months. So very important point to note here is vulnerability should not be thought as an after product. I am a manufacturer, let me build my product and let me deploy the product and then let the product go into the market and I will think about vulnerability later. That's completely a wrong approach. We have to think about vulnerabilities from day one, from the design phase of the product itself, right? And that's where you get into cybersecurity standards. If you follow your cybersecurity standards and process, then you have a best system which is vulnerability proof, or at least the severity of such vulnerabilities will be too less. So what else? We discussed about, like you understand your true villain now. It is about the vulnerabilities that creeped into your system, and CRA is the rule or regulation or an act which is coming into play in 2027. Now you are supposed to get prepared for handling these things, right? Is that all, or is there anything more? Definitely there is more, right? Now there is cybersecurity compliance and there is CRA rule. There are CVEs that you are supposed to manage, but then the fundamental thing is you need to follow some standard. If you follow a standard, or if you follow a process in building your product, whether it is a software or a hardware product, then you will not have vulnerabilities in your system, or you may have, but the severity may be less. IEC 62443 is one such standard which has been worked out very closely with ISA and IEC, and if we follow these standards for all our industrial cybersecurity compliant products, then this will turn out to be a very good process for all of us to deploy. Now, how are each of us responsible for this? So we came here, we are attending OSS Summit, we are some way or the other users of open source software or contributors to open source software, and how are we responsible here, right? And or I am coming as a manufacturer or an SOC solution provider or software solutions provider, how am I responsible, right? I am giving you a simple example. So first thing, a manufacturer, right? So he is the poorest guy. He invests the money, he builds the product, he designs, he innovates, and he comes up with the product, and he passes on the product to the end user. Now, end user is the second poorest guy. He purchased this equipment. Now, after he purchases this equipment, now he is supposed to register his equipment to a portal with his serial number and stuff to notify the manufacturer that I have one equipment with me, right? And then any issue happens, it is now manufacturer's responsibility to upgrade that equipment over the air. So these are the poorest guys, poor characters that who we are dealing with. And 96% of software that is going into any product today has open source element. That means you don't know where this software came from, who wrote that piece of code, and how did it end up into a Git repo, and you have picked that Git repo and you have productized it and pushed into the market, right? And here are a bunch of more poor people. Now, these guys don't know what they wrote. My battery is running. So they don't know what they wrote actually, right? So these guys have much bigger problem to cater to the manufacturer, right? Manufacturer is getting these software pieces from him. And there are some centralized governing bodies and market surveillance authorities who is monitoring all of these poor folks, right? So these are the guys who are making sure the regulations and compliance are established. So what is our responsibility? First, as a user, I am supposed to register my product. As a manufacturer, I am supposed to monitor the vulnerabilities in the system, fix them, and over the air deploy them. As a software supplier, it's my responsibility to ensure that I don't have CVEs in the system before I deliver it to end repo or repository. And as an open source project, I am supposed to comply to all cybersecurity standards. Hope the roles and responsibilities of each of us in the room is clear. So I'll now get into like what exactly we are doing at Texas Instruments to adhere to these IEC standards and cybersecurity compliance, how we are able to manage it well. So I'll hand over now to Vignesh from my team, who will take you through the journey of what we have done at TI.
Good afternoon. I'm Vignesh. I'm one of the kernel maintainers for the TI SOCs. I'll be going through, give an overview of what TI is trying to keep up with the cybersecurity regulations and how we are making use of the open source initiatives to help this make possible. Just to give an overview of the scale that we are dealing with at TI, so we have around 80,000 products and over 100,000 customers overall. So, right. So, yeah, so we design and distribute the software for all of these products. It can be anywhere from simple RTOS to safety certified software to a general purpose OS like Linux that runs on a industrial or automotive subsystems, right? We are strongly an upstream first company. All our code are public and completely feed it up to the upstream repositories. So software are adhered to the cybersecurity and safety standards, and we have a wide range of global network and partner ecosystems to help us out here. Okay, so how are we prepared in terms of managing the CVE and collaborating with that, right? So as I said, to begin with, we are a 100% upstream first company, so we've been working with overall industry standards and leveraging the tools and effectively delivering the ecosystem. Right. So essentially, it's a three-pronged approach. So make sure the code is fully upstream so that it's public and it's ready to audit from this community and it gets all the goodness of it. Then work with a range of consortiums in the public world, like Civil Infrastructure Platform or the ThreadX Alliance or the Trusted Firmware Operation or all the other Linux Foundation ecosystem partners so that we get the industry approved or best practices that is being followed is also deployed for TI products, right? So we also support a variety of distributions. As Khasim was mentioning, some of the distributions with a simple Yocto can go up to 2.5K of packages. So it's essential that the end customers are able to choose an appropriate distribution with minimal set of packages so that they can address the system that they want to build with minimal number of packages, at the same time scale across and build the biggest system possible as well, right? And thus be able to generate SBOMs and track the software that's being used and the vulnerability across it, right? So why do we have to be with consortiums or open source projects, right? Again, as I was mentioning before, it basically streamlines the development and test and across the end equipments. Imagine a company with multiple silicon vendors supplying parts and full end equipment being built. Each end equipment, each silicon vendor may give their own SDKs and versions, which can take lots and lots of different kernel versions. So it may be up to 3 to 6 times the number of kernel versions that they need to maintain versus a silicon manufacturer, right? So therefore, it's necessary that the industry streamlines and adapts to standardization. For example, the CIP project is going towards IEC 64443-4-1 compliance, which gives you cybersecurity standards and provides a way to report vulnerabilities to public channels for industrial systems. Then we have the Yocto project, which you can pretty much deploy for any sorts of end equipment. It has its own CV analysis tools, the Valkyrie automated build systems, and it proactively, generates the CV matrix for a given build, right? So then you have the ThreadX Alliance, which is an alliance under Eclipse Foundation for safety certified RTOS, and they are into long-term support and security management as well. Then, of course, you have the general purpose RTOS Zephyr, which develops along the very similar lines as Linux, and it also has a CV numbering authority and security best practices to maintain and support CVEs, right? Coming to how we are doing inside TI, for the ecosystem and the end users who discover issues with products can report via TI security incident response team. And what TI does is we monitor the CVs from different projects. We are also part of the consortiums through which we get indirect reports of CVs. And when we work with the consortium, we work with the upstream projects, get them addressed, fixed in the upstream first, tested out via CI/CD and test infra pipelines, and then deployed and ported to downstream SDKs based on what customers are building their products, right? What end equipment manufacturers continue to need to do is the additional components that end equipment manufacturers have pulled up on top of the general purpose softwares would have to continue to monitor their SBOMs and track the CVs on top of it, and then work with those projects and open source projects to get the CVs addressed and leverage the TI partner networks if required, right? So, okay, as a last slide, this is the next steps. Khasim, you want?
Yeah. Thank you, Vignesh, for giving elaborative details on what TI is doing in the space of IEC and cybersecurity compliance for all the products. So as next steps, like what are we supposed to do? Like I think you all had a very good analysis of what exactly the cybersecurity compliance is, what is IEC, who the real villains are, and how are we supposed to get prepared in order to meet all the cybersecurity standards, right? So now, so what as a community, what are we supposed to do as an open source community or coming from a different organization? So it is very, very important for all of us to work together. So go through the steps that are very clearly documented on openssf.org, like what an organization should do in order to prepare itself for cybersecurity best practices. For all of us, it is very, very important to understand the CRA compliance, the vulnerability and stuff like this, because we all are contributing to open source software. We all are writing code which will get into the final repositories. There is a lot of AI which is building the code today. Now all these things have to be very clearly analyzed, right? So this is very important for all of us to do. Understand the CVE management, like where are these CVEs coming from, where are we supposed to report, and how are we supposed to fix, how will they get deployed. It is very, very important to understand this. So as I said, CRA is not our villain here. CRA is for all of us to make our lives better, for making our environment secure, and all other cybersecurity threats and all these things are taken down, right? So we have to comply to this act and rule. It is very important for all of us. And we have to, but the industry is actually in a rush to find tactical methodologies and finding quick fixes. We have to educate the industry in making sure we are following the best practices. The most important thing is like we all have to work together and not in isolation, but join these consortiums and work together and find the best solution that which we can all depend and live upon for the years to come. So here are few links if you get to these slides, so feel free to go learn more of these things what I just described. So thank you very much for giving us this opportunity to present and on a very important and key topic for all of us. And for any questions, feel free to reach out to me or any of my colleagues at TI. Thank you.